Hey there, this is Guided Practice 6. We're in section 2.3 on quadratic equations. So remember that we've got a few strategies here to work from. So we can factor. We can solve using square roots. We can use complete the square. And we can use the quadratic formula. Now, to be honest, there is no, you don't need to know all of these things, okay? You can get away with never factoring and never solving using square roots and never completing the square. You do have to know quadratic formula because there are certain ones that can only be solved using quadratic formula, but that will work every single time. So we can always do it using quadratic formula. I'm going to try to avoid quadratic formula unless I can't. That's my only option, okay? So I'm always going to try to factor. I'll probably show you at least one complete the square. And if it's in the right format, we'll use our square roots, okay? All right, so this first one, number 1, we're going to go ahead and set it equal to 0. My default is always to set it equal to 0. So I'm going to go ahead and add the 1 to both sides. And that will give me 4x squared minus 4x plus 1. And now I'm looking for my box and circle here. Okay, so I'm going to go to my box. And I'm going to put my 4x squared up here and my 1 here. And so the 4 is the magic number in my circle. So I'm looking for factors of 4 that add to my middle number, which is negative 4x. And so I think negative 2 and negative 2 was going to work for me. So if I put negative 2x here and negative 2x here, when I add them, it's negative 4. When I multiply them, it's positive 4. And then we factor the box. So in my top row, they both have a 2x. When I take that out, there's a 2x left in the first box and a minus 1, right? So negative 1 times 2x gives me the negative 2x. In the bottom, that for negative 2x spot, I took a 2x above that, so the only thing left is a negative 1, okay? And so I can factor this as, 2x minus 1 times 2x minus 1 equals 0. Now notice that they're exactly the same, so I could even write it as this, right? 2x minus 1 squared equals 0. And then all I have to do is take what's inside and set that equal to 0. So 2x minus 1 equals 0. Add the 1 to both sides to get 2x equals 1. And divide by 2 to get x equals 1/2. Okay, now this one, in this case, this is one repeated root. So anytime you see that I have this perfect square, that's going to give me one repeated root. Okay, on to number 2. Now this one only has one single x, right? And so that tells me that I can use my square roots here. So I can just kind of solve for x and use square roots where I need to. Now I got to remember that if I take a square root, I've got to use plus or minus. Okay, so the first thing I want to get rid of is this minus 12. So let's add 12 to both sides. So that's going to give us, let's see, 4 times x plus 2 squared equals 12. Then let's divide both sides by 4. And that will give me x plus 2 squared equals 3. Okay, now the next thing I want to get rid of is this square on the outside. So to do that, let's take the square root of both sides. So the square root of this one and the square root of this one. But I got to remember when I write it down that I don't want to forget my plus minus. So the square and the square root cancel, and I just get the x plus 2. And then I get plus or minus the square root of 3. Okay. And then I'm going to go ahead and subtract this 2 to the other side. And I usually put that in front of my plus minus. So that's going to leave me with x equals negative 2 plus or minus the square root of 3. And the 3 underneath the square root has no factors that are perfect squares, so I can't reduce it any further than that. So I'm going to leave it just as it is. Next, we've got a 3x squared minus 18x equals 5. Now, because I haven't done it yet, I'm going to go ahead and show you complete the square here. So I already have my constant term on the right side and all my x's on the left. So the next thing I'm going to do is divide through by 3 on both sides. When I do that, I have x squared minus 6x equals 5 over 3. Then I need to figure out what number do I add to both sides. So I look at this number in front of my x. I divide it by 2. So if I divide negative 6 divided by 2, that gives me negative 3. And then I want to square it. And that's going to give me positive 9. So I'm going to add 9 to both sides. Okay, that's going to give me x squared minus 6x plus 9 equal 2. Now I'm going to take 5/3 plus 9 over 1. Okay, so that's 5/3. If I want common denominators, I need a 3 on the bottom, but I got to multiply top and bottom by 3, so that's 27. Then I can add across the top, so that's going to give me 32 over 3. Now on the left side, I can rewrite that as a perfect square. That would be x minus 3 squared is the way you factor that. And that's equal to 32 over 3. Now I can go ahead to solve as if I'm working with my square roots. So let's take the square root of both sides. We won't forget our plus minus. So this is x minus 3 equals plus or minus the square root of 32 over 3. Now 32 does have a perfect square in there. 16 is a perfect square. So I can think of that as the square root of 16 times 2 over 3. And that 16 can come out, but when it comes out of the square root, you have to take its square root. So this is going to be 4 times the square root of 2 over 3, which is what's left. And then I can add 3 to both sides. And that will leave me with x equals 3 plus or minus 4 square root of 2/3. And I'm going to leave my answer like that. Okay, so that's how we would complete the square. And then our last one, and I didn't give you much room here, sorry about that. 3x squared minus 4x plus 6. I haven't used a quadratic formula yet, so I think that's what I'm going to go with. We could try using our box and circle, so we can take a quick peek at that one. We would put our 3x squared here, and our 6 here, and 18 would go in the magic circle, and I would need to create negative 4. Can I create negative 4 from 18? So that would be 1 and 18, 2 and 9, 3 and 6, 4 doesn't go in, 5 doesn't go in. So those are my only 3 options, and none of those, whether you add or subtract, is going to give me 4. So I can't factor. So I'm going to go right to quadratic formula. So that means that my a is the number in front of the x squared, and that's a 3. My b is the number in front of the x, so negative 4. And my c is the constant term, so 6. Okay, keep in mind this has to be solved for equal to 0 for this to be true. And then we're going to plug it into our formula. So the quadratic formula says that x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, and now I want to plug my numbers in there. So that's going to give me, right now I have negative 4 as my b, and negative b is the opposite of b. So negative 4 is going to give me a positive 4. Then b squared would be negative 4 squared, which is 16, minus 4 times a, which is 3, times 3, which is c, which is 6, all over 2 times a, so 2 times 3. That's going to become 4 plus or minus square root of 16 minus 12 times 6 is 72. All over 2 times 3, which is 6. So this is 4 plus or minus the square root of, it's going to be negative. And I get 56 underneath there. Okay. Now this is equal to, the negative comes out as an I, so I can leave the 4 plus or minus. Now the question, does 56 have any perfect square factors? So I'm looking for, remember my perfect squares. I'm thinking 1, which doesn't really matter. We won't take a 1 out, but then 4, 9, 16, 25. So if I divide 56 by 4, that works. That's a perfect square. And I get 14, which is not a perfect square. So, nor does it have any perfect square factors. So I'm going to turn this into the square root of -4 times the square root of 14 all over 6. Now that -4 will become, the negative part becomes an I, and the square root of 4 is 2. So it's 2I times the square root of 14 all over 6. And now you can see that I have a factor of 2, a factor of 2, and a factor of 2 in each of those. So I can cancel a 2. So that one goes, 2 goes into 4 twice, 2 goes into 6 3 times. So that means I'm going to get 2 plus or minus I root 14 all over 3. And that is my x. So in this case, I get 2 imaginary solutions. Okay, so we've seen how you can get all the different things. Okay, you can get, up here we had one repeated root, right? One real repeated root. In number 2, we had 2 distinct real roots, as we had distinct real roots in number 3. And in number 4, we had 2 imaginary roots. Okay, when we get into class, I'm going to bring copies of the practice problems for you, and we'll get started on those.